Hello, I'm Brendan, one of our MCAT tutors here at Inspira Advantage, where we help students get into med school and other professional programs. Today, we're going to talk about the important state functions and phase changes you need to know to do well on the MCAT. The first question you might have is, what is a state function? A state function is something that is intrinsic about a substance and is pathway independent. The state functions you need to be familiar with for the MCAT are pressure, density, temperature, volume, enthalpy, internal energy, Gibbs free energy, and entropy. And no, you don't have to memorize that these are all state functions. You just need to kind of know what these are. So let's go through and define them quickly for you. Starting with pressure. Pressure is the force of all the gas particle/wall collisions divided by the area of the wall. Pretty much you can just think about it as the particles hitting the wall. The next thing is density. This is just the mass per volume. Next, we have temperature, and temperature is not heat. Temperature is the average kinetic energy of the molecules being examined. And then we've got volume, which is just the amount of space in which these molecules are existing. And then we have internal energy, which is the total energy contained in a system. Then we have Gibbs free energy. This is what we're talking about when we say delta G, when we're looking at rate law equations. This is equal to delta H minus delta T S. This is equal to H minus T delta S. And don't worry, we will talk about what these mean in just a second. Delta H is enthalpy, enthalpy, not entropy, enthalpy. This is the total heat in a system or chemical process. And then finally, the last of these vocab words is entropy, which is essentially the amount of disorder in a system. Or, in other words, how spread out are the atoms or molecules? So now to kind of group these, because it's tough to remember all these different things, these last three are all related through Gibbs free energy. We want to think about these when we're examining maybe a rate law, how a reaction is proceeding. We want to calculate the delta G, something we'll be doing later. For pressure, temperature, volume, these can be related through good old PV equals nRT. This is where you'll commonly run into these state functions. Here, where N is the moles and R is just a constant, which is 8.314 in atmospheres. Density you'll use in physics problems, which is something we will cover in the future. And internal energy is something that is going to come into handy when we're doing thermodynamic questions. Typically more easily understood than state functions are the states of matter. And the MCAT is going to expect you to know 4 states of matter and the name of all of the phase changes. Let's begin with the first. Freezing is when a liquid turns to a solid. Vaporization is when a liquid turns into a gas. Then fusion is when a solid turns into a liquid. The next examples are a bit trickier because we don't use this language in our everyday lives. The first is sublimation. Sublimation is when we have a solid turn into a gas. And then the inverse of sublimation is deposition. This is when a gas turns into a solid. And finally, a supercritical fluid is when something is so hot that it exhibits behavior of both a liquid and a gas. On our phase diagram, that is the area shaded in green. Once we get so hot that this line stops, So we could think of it as this line almost going forever, but this line stops right here. So as soon as that line stops, we have now become a supercritical fluid. Typically more easily understood than state functions are the states of matter. And the MCAT is going to expect you to know 4 states of matter and the name of all of the phase changes. Thank you so much for watching our videos on state functions and the different states of matter, and I will see you next time.